Generics in TypeScript. What are they? How do they work? What does the syntax look like? Why are they useful? All those questions will be answered in this video. So first off, there's definitely going to be more advanced things that you can do with generics that I won't cover in this video, but this will give you a good fundamental understanding of how they work and will allow you to start using them within your program. So what are generics? Well, a generic allows you to add variables to your types. And the reason that this is useful is because it allows the type system to be a bit more dynamic and a bit more generalized. So you can use these generics to make a more generic type or a more generalized type and allow a bit more reusability throughout your program, but still have plenty of type safety. So let's go into how these actually work. So one thing you might be thinking is like, okay, if I want a more general type, why don't I just use the any type or some other top type like this? Well, the main reason for this is because when you use the type of any, you really don't have any type safety. So here I have a function called identity. I set the argument to type any and the return value of type any. And you can see that I call this with a number here on line 28, but then I try to access the toUpperCase method on this number. That's an error. And when you use the any type, it's not going to catch this. But good thing, we have generics that we can write this function in a general way, but still have our type safety. So that's what I do right here on line 34. So this is where I start to use my generics here. So here, when I want to create a function that uses generics, allowing me to pass variables in for my types here, I create my function, I give it the label, and then following the label of your function, you can open up a pair of left and right arrow brackets. And a common convention here is to use the label of uppercase T, and it stands for type. And effectively what this means is that when I call this function here, I'm going to pass a type to this function, and then I'm going to use that type throughout my function. So here, after the label of the function, you can open up a left and right arrow bracket, and this is going to be your generic type. And then I can pass a type to this function. And then as you can see, I set my argument to whatever type that I pass into my function here. And then I also set the return value of my function to whatever type I pass into my function here. So you can see how this might be useful because when I call this function, I could call it with a number or a string or a Boolean, and it's going to set my argument to either a number, string, Boolean, whatever I pass in, and it's also going to have me return that same type. So here, when I call this function on line 39, I can pass in my type by when I invoke my function, right following the function label, I can open up a pair of left and right arrow brackets, just like I did when I defined my function here. You kind of match the overall structure here when you call the function, and I can pass in my type. So I pass in the type string. So when I call my identity function, I pass in a string as this variable right here that assigns my argument to type string and my return value to type string. And as you can see, everything works here. This constant here, well, it's of type string because that is what I pass in here and that is what's assigned to my return value. And it allows me to access my string.toUpperCase method. Now, what if I pass in a number here? Well, it's going to throw errors because it's saying, hey, argument of type string is not assignable to type number because I'm still trying to pass a string here when I'm telling TypeScript my argument is going to be a number here because I pass my number as my generic type and then my argument is assigned to that generic type. Same thing with my return value. And then it also doesn't allow me to access this toUpperCase method because the return value should be of type number because that's what I pass here. But if I switch this to just the number 1, then it's okay for me to call it with a number 1, but I can't access the toUpperCase method because it's still a number. But I think I could do like toFixed here, and that's going to be just fine because it expects a number. Now, you don't always need to explicitly pass your type like this with a left and right arrow brackets. And if I remove this, you see that it still works because TypeScript still uses its type inference system to infer that, okay, if I'm calling this with a number here, then the type that I'm passing to this function, it must be a number. So you can still use inference here, but sometimes I do like to explicitly say, hey, I want to pass a number to this function in this instance. But then I could call this function several other times, and I could pass a string to this function. We'll just change the name there. And you can see that I can call this function several different times and just pass different types to it. And it allows this function to be more generic because I use generics within this function. Now, one thing to note when using generics is that you might need to use a little bit more type narrowing within a generic function. So what do I mean by this? Well, here on line 45, I have my very same identity function here. What you see is that within my function, I try to access my argument.length property, but I get an error. It's saying property length does not exist on type T. And that is because since I can pass any type to this function, TypeScript's like, hey, this .length property, it doesn't exist on every potential type that you might be able to pass to this function. So within the body of this function, the way that I can correct for this is I can add a type guard here, and I can narrow this type, and I could use the array.isArray method, pass in my argument, and then I'm saying, okay, well, if it's an array, then I can check the .length property, but only if it's an array. And that's going to be okay because I've narrowed this type to just potentially being an array. All right, so when you use generics, since they are more generalized, you might need to use a little bit more kind of type narrowing and type guards when kind of defining your generic functions. Now, you're not just limited to using generics with functions, and you can actually use generics when writing an interface as well. So here, I'm going to create an interface, but I'm going to use a generic interface. So here, I'm going to create my interface, and I'm just going to call it generic value because I am very creative with my naming conventions. And just like how behind the function label, you open up a pair of left and right brackets and then give that kind of your variable for your type, you do the same thing with interfaces here. I can open up left and right brackets, and then I can open up my interface, and now I can use this type within my interface. So let's just say that I have a value property, and it's going to be of type T. All right, so I can pass a type to my interface here, and that is going to assign the type of this value property to whatever type I pass into my interface. So if I want to use this now, I can say const value that is going to be of my generic value. Well, I can do the same thing I did before. I can call this with some type, and here I'll call it with a number. Now, when I assign this to a value here, well, I'm going to need to assign it to an object that has a value property that is of type and number, because that is what I pass as my generic type. So here, I'll do value as 1, and TypeScript is all happy with this because I pass in a number type here, so it expects me to have an object here that has one property that is value, and it has a number type, and that is exactly what I do here. But if I change this to a string, it's not going to be happy because it's saying string is not assignable of type number because I pass a number as my type here. So it gives my value a type of number. So this is not valid. But if I were to pass a string here, that's totally fine and that works. Because value is now expected to be a string because I pass it as a string right here to my generic type and assign the value to of type string. All right, so hopefully this gives you a good example of how these generics allow you to create more generic types and more reusable types within your programs. And you can use them for functions, interfaces, types, and different things like that throughout your programs. Hopefully that gives you a good fundamental understanding of how generics work. Now, some people get a little bit confused with the type narrowing that I did earlier. If that is you, make sure to click the video on the screen here. But if not, I will see you in that next one.